we are going to learn a special order for graphing sine and cos when we have all four transformations. Vertical stretches, compressions, horizontal stretches, compressions, shifts left and right, and translations up and down. Now, normally when we went from chapter 3, we always did our stretches and compressions first, and then our translations. With the special order, we actually start with the d value. I even have an acronym to remember the special order. I call it DAB-C. Okay. So with your d value, the reason you can start with the d value is because the d value represents your sinusoidal axes. Does it make sense when you multiply something by your sinusoidal axis, which is at 0, it stays at 0. The only thing that affects your sinusoidal axis is shifting it up and down, is your vertical translation. So you can start by drawing your sinusoidal axis wherever your d value is. Our a value, a vertical stretch or a vertical compression, our a value affects our amplitude. And so we can use our amplitude and our sinusoidal axes to find the max and the min values. Does it make sense if your sinusoidal axis was at 3 and your amplitude was 2, that your maximum would be 3 plus 2, 5? And your minimum would be at 3 minus 2, 1? So we can use our amplitude to label the maximum and minimum values on our y-axis. Our b value. Our b value is a horizontal stretch or compression that affected our period. So we're going to use our b value to find our period. And we've got that formula from the other day that our period is 2 pi divided by our b value. We then can label our period on the x-axis. And because our regular sine graph was divided into the 4 equal sections of the axis family, whatever your new period is will need to be divided into 4 equal sections. In DAB-C, the dash actually means something. The dash is there to tell you you need to graph your function without a phase shift with a dotted line. So the dash is to remind you to graph it with a dotted line before you do the phase shift or the horizontal translation. Then finally, your c value, you just need to translate your graph left or right based on whatever the phase shift is. So you're going to find that this shortcut or this method will allow you to graph it a lot quicker than if you used the techniques from chapter 3. It's not wrong to use the techniques from chapter 3, but you would have to have 5 main points from your parent graph from sine, and you'd have to do all of your calculations with all 5 of those points. Chances of a mental math error increase quite a bit. So we're going to do a couple of examples right now in this introduction to see what this looks like. So if you were asked to graph y equals 3 cos 2 x minus pi over 4 plus 1. Okay, off to the side. Sorry, did I scroll down too fast? Was everybody done the other stuff? Yeah? Okay. So off to the side, I'm just going to write DAB-C. as sort of a checkpoint for myself. I'm going to start with my d value. Draw my axes. And with a red pen, dotted line, my d value is 1, so my sinusoidal axis will be 1. I can put a check mark beside the d. That part of dab C is done. That's all we need to do with it. Second, the A. A is for the amplitude. The amplitude of this graph is 3. Remember, the definition of amplitude is the distance from the center line or sinusoidal axis to a maximum, or the same distance to a minimum. So if the distance from my sinusoidal axis to my maximum is 3, I go up 3, I can label my maximum point is at 4. Going down 3, my minimum point is at -2. We've now finished the A part. B. The B value helps us calculate our period. So if I use the formula, my period is equal to 2 pi divided by my B value, can you see that your period is going to be pi? So we go somewhere along our x-axis, mark pi, because that's our period, and divide it into 4 equal sections. Half of pi is pi over 2. So that's the next one that you can label. Half of pi over 2 is pi over 4. So I would label that one next. And then I would count by pi over 4s, since these are equal sections. 1 pi over 4, 2 pi over 4. This one will be 3 pi over 4. That's all you have to do with the B value. Figure out your period, draw it, and divide it into 4 equal sections. Now the dash. For the dash, we need to draw a cos graph. I've said this a fair bit already, but where does a cos graph start? At a maximum, right? A sine graph starts in the middle going up, or on our sinusoidal axis going up. I never said, let's try to stay away from saying sine starts at 0, because sometimes it's going to move up and down, right? So the sine graph always starts on the center line, or the sinusoidal axis going up. A cos graph always starts at a maximum. So my maximum's at 4, and then each of these 4 sections tell you go from maximum, center line, minimum, center line, maximum. And draw that with a dotted line. We've now completed the dash. The period is pi. How long does it take to get from here to here? Pi. So that's the why we draw that period on our x-axis and divide it into 4 equal sections, so that you can do that max, centerline, min, centerline, max, centerline, min, centerline, and it would keep on going forever. Finally, we need to draw our final shift. This one's going pi over 4 to the right. We're lucky, pi over 4 is already labeled on our x-axis, so we don't have to do any extra labeling. And we need to take each of these 5 points and just shift them pi over 4 to the right. And once you figure out the distance for the first shift, the other ones are the same distance. And we've got our final graph. So we can put a check mark by C. And we're done. Yes?
The original graph before the translation and dotted?
I draw the dash one. Otherwise the translation, it's hard to see it. So I draw it first without the translation, just as a dotted line, and then the final one as a solid line. So that's the technique of DAB-C. We'll do one more. Ready? All right. DAB-C again. Yeah, if you need more space, you can turn back to page 529. There's lots of space on there. This is the last one that we're going to do besides our notes. Okay. Yeah, go turn back a page to 529. There's lots of room on there. Okay. Now, when I draw my axes here, how did I know to do this? What are some of the things that might tell me that I want to draw my axes like that? Last time I drew my axis down lower. Yeah, because I was already looking at my d value to be -2. So I knew to begin with that I'm going to have a -2. And my amplitude, there's a -4 out in front. Would we say that our amplitude is 4, or would we say that our amplitude is -4? 4. Amplitude is a distance. It's always a positive number. So if our amplitude is 4, that means we're going to go up 4 and down 4. So our maximum is at 2 and our minimum at -6. Ooh, sorry, I got ahead. Check the D, check the A. Perfect. Next, our B value. That calculates our period. Our period formula is 2 pi divided by our B value. So our period's going to be 2 pi over 3. Pick a random spot. Label it as 2 pi over 3. Divide it into 4 equal sections. So cut it in half, cut it in half again. Half of 2 pi over 3, 2 pi over 6, which reduces 2 pi over 3. Yes?
Why is the D inside the bracket? Like before it was outside, does it matter?
It needs to be in factored form. Okay. I added extra brackets on this one. Right? This one, there could have been extra brackets here, but they're not necessary. Good question. Okay. Half of pi over 3, pi over 6. Count by pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. Are you okay if I reduce that to pi over 2? We've now done the B value. Next, the dotted line. And I chose this one. Okay, it's a sine graph, so it's starting on the center line. A normal sine graph starts on the center line going up. But we have a vertical reflection here. It's going to start on the center line going down. So we start on our center line. Going down means we'll go to minimum to center line to maximum to center line. A sine graph always starts on a center line. And so this question has a sine graph. It's a negative sine graph. It's got to be going down because of a vertical reflection. Yeah, for cos starts at a max. A negative cos would start at the minimum. So we've now done the dash part. And finally, the phase shift. We need to go pi over 6 to the left. Okay? We've got pi over 6 already labeled on our graph. So you would know if I go the same distance, that's where negative pi over 6 would be. I take each of my points and shift them over that distance. And now we've done the C part. And we've graphed it completely. these questions are almost always out of 4 marks. I think this one might even be out of 5 marks on a final exam. Because you get 1 mark for the D, 1 mark for the A, 1 mark for the B, 1 mark for the C value. And because it was a reflection, they might give an extra mark for that reflection. They're not that bad, but you do need practice with them. Okay, the DAB C really makes it easy. I'll give you some, yeah, there's lots of practice in the textbook, and then we're going to do an activity practicing them even more.